Hi everybody, in today's lecture we are going to study about cyclic permutation. Now first of all we see the definition of cyclic permutation. Cyclic permutation means arrangement of elements in cyclic manner. In cyclic manner is called cyclic permutation. Is called cyclic permutation. Okay, so for if you consider and remark related to it is arrangement of n objects. Arrangement of n objects in cyclic permutation. In cyclic permutation can be made in n-1 different ways. In n-1 factorial different ways. Okay, so that means if there are n objects, then it can be arranged in n-1 factorial different ways. For example, if you consider in how many ways can 10 person sit on merry-go-round having 10 seats, having 10 seats. Okay, that means here n is equal to 10 and merry-go-round, this merry-go-round is arrangement of person in cyclic manner only. It is a cyclic manner. Okay, cyclic means we will round shape arrangement, or when we start from a point and end at that point only, that type of arrangements are known as cyclic manner. So here total distinct ways to sit on merry-go-round is equal to n-1 factorial. And here n means, here it is given that it is 10 persons sit on 10 seats, so it is n is equal to 10, so which is n-1 factorial, 10 minus 1 factorial, which is 9 factorial, which will be our required solution. Okay, now consider next example. If I consider in how many ways can 9 people be seated at a round table if there is first condition given, they can sit anywhere, and second we have to find total particular person must not sit next to each other. Now in first case it is a simple one. In solution they can sit anywhere, that means there are n is given as a 9 people be selected at a round table, which means it is of an cyclic permutation. So for first, since people can sit anywhere on a table on a round table. Therefore, and round table means it is in cyclic permutation. Okay, so there are n minus 1 factorial ways, which is equal to n is here 9 people, so n is equal to 9, so 9 minus 1 factorial, which is equal to 8 factorial ways. Okay, so first answer is 8 factorial. Now for second, consider two persons. We have to find a total particular person must not sit next to each other. Okay, so in that, first consider two persons pair. Consider two persons as a single person. Okay, because in question it is given that it will not sit next to each other, so we have to consider two persons as a single person. That means it is considered as a single pair. Then there are 8 persons. Then there are 8 persons all together, and they can be seated in 8 persons all together, and they can be seated in 8 minus 1 factorial is equal to 7 factorial ways. 7 factorial ways. But the two particular persons, or into bracket pairs, can be arranged among themselves in 2 factorial ways. Okay, thus the number of ways of arranging arranging 9 peoples at a round table with the two persons sitting together, is 2 factorial into 7 factorial, and its calculation will give us 10080 ways. Okay, now for first, it is 8 factorial ways for setting 9 person on a round table. That means its total calculation is 40320 ways. Okay, now from first case, the total number of 9 peoples, the total number of 9 peoples can be seated on a round table so that 2 persons do not sit together is equal to, now total number of peoples on a round table can be sit in the ways 40320 ways. That means this is the first case. From first case we can say that 9 peoples can be seated on a round table in 40,320 ways. And from this, the number of ways arranging 9 people at a round table with 2 persons sitting together. That means in this case 2 persons are sitting together. So there are 10,880 ways. Okay, so we have to subtract from this 10080. From 40,320 we have to subtract 10,080, which will gives us 30,240 ways. That means we have here subtracting the peoples who are sitting together. So there are 10,080 ways, so that the peoples are sitting together. Okay, so now this number which we have get 30,240 is our second answer, that is total particular person must not sit next to each other. So which is our required solution. Okay, so in this example you must consider this step is an important step, because in this we have considering first 2 person as a single person. So from 9 2 persons are subtracted, so there are only so 2 persons considered as a single pair, so 9 minus 2 is 7, but it is considered as a single, so we are getting 8. N will be 8 over here, and 8 minus 1 is equal to 7 factorial ways can 8 person altogether can be seated on a round table. After that 2 factorial is getting by 2 particular persons can be arranged among themselves. That means 2 persons can be seated themselves in 2 factorial ways. Okay, so here it is 2 factorial, and product of this 2 will give us the number of ways arranging 9 peoples at a round table with 2 persons sitting together. So it will give 2 factorial into 7 factorial is equal to 10,080 ways. And from our 9 persons sitting round a table, we have to subtract 40,320 minus 10,080. We will get a required answer of a person not sit next to each other. Okay, which is our required solution. Okay, so this is the example related to cyclic permutation. Next is a permutations with repetition. Now in this there is a formula related to permutation with repetition. It is given by P of n is semicolon R1 comma R2 comma R3 up to Rn, which is equal to, here n is the number of elements in that, and in this repetitions is R1 factorial, first repetition R2 factorial up to Rn factorial. That means it is given that if there are n objects, if there are n objects, R1 of them are alike. That means from n R1 elements are same. Okay, R2 of them are alike, same. That means R2, number of R2 elements are same from n objects. R3 of them are alike, R3 of them are alike, and continuously Rm, here it is Rm, persons are alike, Rm of them are alike, where R1 plus R2 plus up to Rm is equal to again n. Addition of this R1, R2, R3 up to Rm will gives us n object. Okay, then number of different arrangement of these n objects denoted as p of n semicolon r1 comma r2 up to rm. Rm here it is rm, and defined as here it is defined p of n semicolon r1 comma r2 up to rm is equal to n factorial upon r1 factorial into r2 factorial into rm factorial. Okay, for example, find the number of ways to arrange the 6 letters in the word follow. FOLLOW. Okay, 1 2 3 4 5 6. There are 6 letters in the given word follow. Now in the word follow, F is repeated here. F is one time only, so it is repeated one time. Next O is repeated 2 time. Next L is 2 time, and next letter is W, it is again 1 time. Okay, that means here different number of arrangement of these 6 letters are is equal to, here n is 6, so n factorial upon, here first f is repeated one time, r1 is 1 factorial, second O is repeated 2 times, so it is 2 factorial, next it is 2 factorial and 1 factorial. We have, if we done the addition of this 2 plus 2 4 plus 1 5 plus 1 6. Okay, we will get n. Okay, so here n is 6, so here answer is 6 factorial upon 1 factorial into 2 factorial. Now 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. Okay, now here 2 factorial, 1 factorial is 1, 2 factorial is 2 into 2 factorial is 2 again. Okay, so 2 will 2 get cancelled here. Next here 2 ones are 2s are, so total calculation will be here 3 2s are 6, 5 6 are 36, and into 5 is 180. So there are 180 ways to arrange the word follow. Okay, next example, how many ways arrangement are there of the word Mississippi, MISSISSIPPI. Okay, so this is our word given. Okay, so in this, first of all find, we have to n. So here in the word, we will check here in the word Mississippi, MISSISSIPPI, Mississippi. M is repeated here. M is a single time, so it is 1 times. Next is I is here 1 2 3 4, it is a 4 time. Next yes, here yes is 1 2 3 4 times. Next after yes it is P, it is 2 times. Okay, If we check here, M, I, S, next P. There are 4 letters in the word Mississippi. Okay, and this total calculation is 4 plus 4 8 plus 2 10 plus 1 11. Okay, so if here we will count this are 11 letters or not. 1 2 3 4 5 6 7 8 9 10 11. So that means here n is equal to 11. So our number of arrangements will be equal to 11 factorial upon, here it is 1 factorial into 4 factorial into again it is 4 factorial and into 2 factorial. So which will equal to 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial divided by, here 4 factorial can be written as 4 into 3 into 2 into 1. This is 4 factorial. This 4 factorial we will keep as it is and 2 factorial as 2 into 1. So 4 factorial value will get cancelled. 2 ones are 2 threes are. Here 3 will get cancelled. 2 ones are 2 fours are, and this 4 will get cancelled. So our total calculation will be 11 into 10 into 9 into 7 into 5. Okay, so its calculation after it will gives us, so last answer is 34,650 ways. Okay, so we can arrange a word Mississippi, letters in a word Mississippi in 34,650 ways. Okay, for example, for homework you may solve it for a word mathematics. Next, Maharashtra. Okay, so this two example you have to solve as a homework. Okay, now consider next example. In that only, in how many ways can 4 identical red pens, 6 identical green pens and 4 identical blue pens be arranged. That means in this question it is given that 4 identical red pens, that means 4 red pens are same, 6 green pens are same and 3 blue pens are same. So here number of identical red pens is equal to 4. Next, green pens is equal to, it is given 6, and blue pens are, it is 4. Okay, so total n is 14, so n will be 14. Therefore total number of arrangement is 14 factorial upon 4 factorial into 6 factorial into 4 factorial. Okay, so which will be our required answer. Okay, or you may calculate it will gives us, so here we get answer 210,210 ways. Okay, which will be our required answer. Okay, so for today we will stop here. In next lecture we will go toward combination. Thank you.